This lesson is on comparing decimals, meaning using the greater than, less than, or equal to sign to compare decimals. Before we get to comparing decimals, let's do a little review on comparing whole numbers. If you remember, we always start looking at the greatest place value. So in this problem, we would look at the thousands place. Well, those are the same, so that doesn't help us, so we move to the next smallest place value, which is the hundredths. Still the same, so we move to the tens. Here we have a difference in value, and we know that 7 is greater than 3. Therefore, 6,972 is the greater number. It does not matter what is behind those digits. The first place we have a difference is the tens, so that's where we find the difference. We are going to use that same process when comparing decimals. So we start at the greatest place value, which for these two numbers is the ones place, but they both have the same digit, so that does not tell us anything. Moving to the right, the tenths place also has the same value. So we have to move one more to the hundredths place, which is where we find our difference. So here that tells us that the bottom number is greater because the 6 is greater than a 1. Again, it does not matter what is behind that. It doesn't matter that a 7 is more than a 2 because we know that hundredths have a greater value than thousandths. Here's an interesting example. Many fifth graders look at these two and they say the top number obviously is larger because it has so many more digits. But if we understand decimal place value, this is the first place, the hundredths is the first place that we find a difference, and 5 is greater than 2. So actually 4 and 35 hundredths is the greater number because we could fill all of these place values with zeros, and then I think it would be obvious that the bottom number is the largest number. You need to be careful when comparing decimals, not to just look at how many digits there are, but actually compare each place value. Models can be very helpful when comparing decimals. So our first number is 1 and 8 hundredths, which would be 1 whole, and 8 hundredths, which would be just that much. Our second number, 1 and 75 thousandths, again 1 whole, but only 75 thousandths, which means we have 7 hundredths and then just 5 little thousandths. So although these are very close in value, you can see that in the first one, this spot right here is totally empty, and here we have 5 filled in, and here this is all filled in. So 1 and 8 hundredths is greater than 1 and 75 thousandths. We could also compare decimals using our 3D models. So we have 265 thousandths compared to 28 hundredths. So if the cube represents a whole, 265 thousandths would be represented by this, and 28 hundredths would be represented by this, which it might look very similar. This doesn't have any thousandths, but if you count here, this has 6 hundredths and this has 8 hundredths. And because the hundredths have more value, 265 thousandths is less than 28 hundredths. Another way we can compare decimals is on a number line. So here we have 305 thousandths compared to 35 hundredths. And we know, because of the 3/10ths, that both of these would be somewhere in this region. But if we look at the hundredths place value, 35 hundredths would be right in the middle. But 305 thousandths doesn't have any hundredths, so it would be just past 3/10ths, which shows us that 35 hundredths is the greater number. Some of the trickiest parts of comparing decimals are dealing with the zeros, so let's look at some of these. Here we have a bunch of zeros and 1 6. Because the 6 is in the same place, the zeros behind it don't matter, so these are all equivalent. Here, again, 7 in the 1s, the zeros, but the 3s are in different places, so the top number, 7 and 3/100ths, is greater. 5 hundredths is more than 5 thousandths. Zeros after the last decimal place value mean nothing, so these are equivalent. Here, although there are lots of zeros and only 1, 2 in each number, they're not in the same location, so the bottom number here would have a greater value. For the next few slides, I want you to look for a little bit and then decide if a greater than or less than sign would belong between these or equal to. Pause the video, write down your answer, and then resume video for the answer. 53 and 26 hundredths is equivalent or equal to 53 and 260 thousandths. 3 and 49 hundredths is less than 3 and 5/10ths. "57 and 6 hundredths is equal to 57 and 60 thousandths. "546 thousandths is less than 564 thousandths because of the hundredths place. "50 and 9 thousandths is less than 50 and 1/10 because of the tenths place. 1/10 has way more value than 9 thousandths. Okay, once you have completed this video and think you understand comparing decimals, you're going to work on Interactive Notebook page 10. So after you glue it all in, it should look something like this. And each one of these question marks is going to be a flap with the correct greater than, less than, or equal than sign in it. This other part is not a flap. You are just going to write in the circle the greater than, less than, or equal to sign. So for one of these, what I would do is when they have it in expanded form, like this example, I would write it in base 10 numeral form, and then I think it will be easier to compare. So for example, I have a 4 in the hundreds place, a 5 in the tens place, a 7 in the ones place, a 2 in the tenths place, and a 9 in the hundredths place. So now if I compare the two numbers, I notice that in my ones place, here I have a 7, and here I have a 0. So it does not matter what's behind the decimal because the ones place is different. Therefore, 457 and 29 hundredths is greater than the other number. Okay, you can complete the rest of page 10 on your own.